Systicon are experts in producing world-leading logistics software. The tool suite includes CATLOC. CATLOC accommodates all the primary uses of lifecycle costing, or LCC for short. As different uses may require different LCC models, CATLOC allows the LCC model to be defined by the user. This allows the cost breakdown to follow a predefined standard model, or for the user to specify their own. This demonstration describes how a model in CATLOC is defined. Like other Systicon tools, CATLOC primarily uses a series of forms to define the problem. Many of the forms allow the detail of the model to be enhanced, but only a small number of forms are needed to detail most problems. It should be noted that having a good understanding of the planned cost model and what is required from it is a prerequisite to building a model. The user interface is very similar to that used for Opus 10. Indeed, many of the features from Opus 10 are included, including the use of templates and the ability to hide elements not required for all models. This overview uses the default CATLOC template and does not show some hidden features. We'll look at building a problem from scratch. Whilst we will be working through the forms, there is no predefined order. The model can be built in any way the analyst wishes. We will start with the case description table. This is a free text table that allows the analyst to describe the problem. Next is the case settings table. Here the overall model parameters are set. In CATLOC, cost aggregates are costs that include other cost elements. The lowest cost elements that can be analysed are called cost atoms. These cost atoms can be pooled and used to derive cost aggregates, which in turn can be used to derive other cost aggregates. For this example, we will be using this cost model. Cost aggregates are declared in the cost aggregates table, and cost atoms in the cost atom table. The next table is the cost structure. Here we define the view or views of the cost model. For clarity, the target cost model is also being shown here. At this point, absolute values could be directly assigned to the cost atoms and calculations made, but this would reduce the ability of the tool to show costs in any great detail. Alternatively, cost atoms can be determined from parameters or functions. The next table we will consider is the parameter table. Here, all parameters to be included in the model are defined, together with their defining functions if applicable. Note that the table also allows parameters to be assigned to dimensions. In CATLOC, costs can be allocated to one or more of 5 dimensions: material, task, resource, station, or time. This is done by declaring user-defined domains within each dimension and assigning costs to each domain where appropriate. For example, the analyst may wish to derive costs assigned to the repairable items. By defining a domain in the material dimension, all repairable items can be assigned to that domain. Domains are defined in the domain table, and a domain structure can also be defined if required, using the domain structure table. Before we proceed further, let's return to the cost atom table. All the columns are now shown, and we can see here that cost atoms can also have functions assigned and be allocated to dimensions by assignment to the appropriate domain. Having defined the cost model, all that is left is to add the detail. For example, define the system breakdown, logistics support organisation, task, resources and time breakdowns where required. Again, the complexity here will depend on the questions to be answered or the data that is available. For this demonstration, we will focus on the material dimension, but the methods are similar for the other dimensions. All systems and items are declared in the material table, with entries assigned to domains where appropriate. For example, repairable items assigned to the repairable domain. The system breakdown is defined in the material structure table. Note, no costs, fits, or other values are assigned here. These are values that will be assigned to the parameters and used to determine the costs. Whilst the model is being built, the structures can be checked using the structure view. Here, for example, we can view the material dimension, either by using the equipment structure or by viewing the domains and seeing what is included in them. Once the cost model and data for each dimension have been entered, values can be assigned to the parameters. If this is to be done through the table view, then entries are placed in the parameter value table. Parameter values can be set as overall default values by ignoring the dimensions and only assigning a value. This default can be overridden by declaring entries that include, say, a station. This can then be overridden by declaring a value and assigning it to, say, an item and station. This ability to define defaults at various levels allows models to be built quickly with little data. As data becomes available, the values can be refined. In addition to the table view for entering parameter values, there is a parameter view. Here, parameters can be displayed and their values entered where necessary. It is also possible to determine how a value is derived. All values entered here are recorded in the parameter values table. Whilst being built, the model can be tested at any time. This will generate a comprehensive log window, which allows the user to quickly identify and track down problems with the defined data. This same test and log window are used when the model is executed. It's important to note that this is merely an overview of the model, and many features have not been covered. For more information about our tools, please select another demonstration. Or for more detailed information about our products, please contact us or visit our website at www.sisticon.co.uk.